Hi everybody, this video is about writing Ionic equation. So if you have problems writing Ionic equation, please watch on. Okay, now how to write an Ionic equation? I have split them into the following steps. First, you must make sure that you have written the full chemical equation with state symbols. Now, if you do not know how to write the state symbols, you need to first memorize the solubility table, so that those that are soluble you put aqueous, those that are not you put solid, and of course the rest, be it gases or liquid, etc. Now next, after you have written the full chemical equation, you are supposed to split those ionic compound into its ions. That means into its cation and its anions. Those that are soluble. Now if it's S, that means it's not soluble in water, you do not need to split it. If it's covalent, you can also leave it alone. Okay, and this will save you a lot of trouble. Now, next, compare each term before and after. Those spectator ions which did not change state, that means their state symbol remain the same. Number two, their formula also remain the same. In such a case, we call it a spectator ion. Such ion, you remove it. After you have removed all the spectator ions, you are left with your ionic equation. And those ions which came from the same compound, you combine them together. If they do not come from the same compound, you just leave it as it is as an ion state. So, now I know it's a bit hard to visualize, so we're going to do a few examples. We're going to do 3 examples. Okay, example 1. This is acid plus carbonate. So we have sulfuric acid added to sodium carbonate to give you your salt and carbon dioxide and water. Now, make sure you have written all the state symbol correctly. If your state symbol is wrong, your ionic equation is most likely also going to be wrong. So it's very important you make sure your state symbol is correctly written and you check whether it's soluble or not soluble. So sulfuric acid is aqueous. Sodium carbonate is a sodium salt, so it's confirmed soluble, AQ. To get this sodium salt, AQ, carbon dioxide, water are gases and liquid respectively. Now, so the first thing to do, remember, you have written your chemical equation. Next, you write in your state symbol. Now, what you do, you split those compound, ionic compound, which are soluble. So those AQ1 we must split. So if you can see here, my H2SO4 I have already split into H plus and SO4 2 minus. Now, the state symbol of the ion will follow the state symbol of its original compound, where it's being split from. Na2CO3 we also need to split, so I have split this accordingly. On the other end, on the product side, Na2SO4, same thing, is AQ, so we need to split. So we have Na plus and SO4 2 minus. CO2 and H2O are covalent compound, and we leave them as it is. Okay, now we will have to identify who are spectator ion. If you look at SO4 2 minus and SO4 2 minus on the product side, you can see that the formula didn't change, neither did the state symbol. So this is a spectator ion. We cross it out. What else? Na plus. This is also spectator, so we also cross it out. 2H plus AQ. Now that it has become H2O, it has combined with an OH to become H2O. So this one, the formula have already changed. So we didn't bother. So it's obviously not a spectator. CO3 2 minus, it has also become CO2. The formula have changed. So it's also not a spectator. So now what do we do next? We write all this down. So 2H plus AQ plus CO3 2 minus AQ plus CO2 plus H2O. Now, then the last step, you need to see whether there is any of these ion that come from the same compound we put them back together. In this case, we do not join back H plus and CO32 minus because they come from separate compounds. CO32 minus came from sodium carbonate. The H plus come from the sulfuric acid. So we just leave them as it is. And this is your ionic equation. Let's do one more example. This one is a carbonate, but this is another carbonate example plus acid, but I have chosen a carbonate that is not soluble in water. So I want to let you see the difference. So same thing, we start off with a chemical equation and the respective state symbol, and we split it into its component. So H2SO4, the sulfuric acid, is aqueous. MgCO3. Now, if you check the solubility table, this is all carbonate are insoluble except group 1 and sparse salt. Basically, except sparse salt and group 1. So magnesium is group 2. So magnesium carbonate is insoluble. So you take note, we did not split it. I keep it as it is. There's no need to split it. Even if you split it, you realize that you do extra work. Also, just keep it as it is. MgSO4 is aqueous. Sulfate, all right, magnesium sulfate is aqueous. So we have to split it. It becomes Mg2 plus and SO4 2 minus. Same thing, the state symbol must carry down. CO2H2O, we keep it. Now, if you realize, SO4 2 minus, our sulfate, is still our spectator ion. So we're going to remove this from our ionic equation. MgCO3. Now, Mg2 plus aqueous, but it was Mg. Even if I split it, you just tell me Mg2 plus solid. So this actually, even though the formula might not have changed, they have actually changed the state symbol. So it's not spectator. We're going to keep it. Same for the H plus. So now we just bring down the rest. We're going to have 2H plus, aqueous plus MgCO3, and you get magnesium 2 plus, AQ plus CO2 plus H2O. Okay, there's no source that we can combine, so this is our ionic equation. Now, if I'm too fast, just pause, try on your own. Okay, last example. When aqueous chlorine displaces bromine. Okay, I think if you have done your periodic table, that chapter, you will see that there's this displacement of halogen, where the more reactive halogen will displace the the less reactive halogen. So in this case, we have chlorine, aqueous chlorine. That means it's already dissolved into water, reacting with potassium bromide. Now, because bromine is less reactive than chlorine, the chlorine will displace the bromine and then combine with potassium instead. So this is the full reaction, the full chemical equation that we written out. Notice that that's why it's AQ. Now, if you are not dissolving the chlorine in the water and you are bubbling it through potassium bromide solution, then the state symbol here will be G. But in this case, I said aqueous chlorine. In fact, when you are reading the question, be very mindful of all these terms. If they say aqueous means it's AQ. If they say chlorine is bubbled through, then it should be state symbol G. Okay, now let's continue. Same thing, those that are aqueous, you have to split it. But only ionic. Now, chlorine chlorine gas is a covalent compound. Even if it's aqueous, we keep it as it is. So that's why you see I don't split it, it remains. But this potassium bromide solution, potassium bromide is an ionic compound. we have to split it. So 2K plus AQ, 2Br minus, and then same thing for potassium chloride. And bromine, we keep it, or we don't split. Now, if you notice, you'll see that our potassium ion is our spectator. So this we will remove. And the rest are not spectator. Why? Because you see Br minus AQ, it becomes Br2. The formula changes. So it's not a spectator, it's active. Same thing, Cl2 becomes Cl minus, is also not a spectator, is active. Then we write down all this. Okay, there's nothing to combine also. Br minus is alone. Here Cl2 is already by itself. So this is our ionic equation. Now hopefully you can understand. If you have any queries, feel free to leave comment below. If this has helped you in any way, please like the video and subscribe. Thank you very much.